Good day, everyone, and welcome to the GTAC Tech Talk webinar on Omnicast video redirection. My name is Derek. I'm a technical support representative with Genetec, and I'll be your host for today's webinar. We also have other members of the Genetec Technical Assistance Center standing by to answer your questions during the webinar. Just type them in the questions section of the GoToWebinar console, and someone will get back to you shortly. If there are any questions that we cannot answer in the time we have today, we'll be sure to send you an email with your answer. We'll also be posting the questions and answers from today's session in the Genetec Technical Assistance Portal forums under the GTAC Tech Talk section. If you have any comments or additional questions on the webinar or the GTAC Tech Talk webinar series in general, you can post those here as well. Also to be found on the GTAP are the videos from previous webinars. Just go to Tools, then Videos, and click on the GTAC Tech Talk section. You can either watch a streaming video in your web browser by clicking on this icon here, or you can download the video in WMV format for viewing offline by clicking on the second icon right here. There's some additional material that we won't be able to cover in the time we have for today's webinar, but we will be posting a document on this subject on the GTAP soon. You'll be able to find it by going to Tools, and then Documents, and selecting Omnicast as the product type. So let's take a look at the subjects we're going to be covering today. First off, we'll do a general overview of video redirection, covering what video redirection is, the 4 key components in the video redirection plan, and we'll take a look at the various connection types. After that, we'll examine the various video redirection scenarios based on the connections on the network, and the type of stream being viewed, either live video or video playback. We're going to use that information to go over some of the most common configurations we have seen at client sites, and give you some real-world examples to help explain where we might see these configurations. So that's the core part of the webinar, which should take us around 40 minutes. And after that, we'll take a little time to go over a quick summary of the key points of the webinar today, and then take a look at some of the most frequently asked questions we have had. So before we start looking at network diagrams and connection types, we should talk about what video redirection is in Omnicast. There may be other definitions of video redirection out there, but when we're talking about it within an Omnicast context, we really mean the mechanism to automatically transfer video traffic from one server to another to reach a final destination. Basically, the traffic is going from a source through an Omnicast server and being routed to a different destination. Our goal is to get our live video stream from the IP cameras or encoders here to the live viewer client applications. If it can't get through, we get the infamous waiting for signal message in our live viewer tile. Similarly, we want the video playback from our archivers to get through to the archive player client applications. We're not going to cover video playback directly from the units, as it is a more complex subject, and the topic of video redirection will take up all of our time for today. There are 4 major components involved in getting the live video from the source to the destination, which you will see consistently throughout the presentation today. The first major component is, of course, the video unit. When I refer to video units, it can either be an IP camera or an analog camera connected to a video encoder. This is our first link in the chain when looking at the live video stream. The second link is the archiver the video unit is connected to, since the one doing all the communication with the unit. Our third link is the gateway that the archiver is connected to, and at the end of the chain is our destination, which are our client stations which can be running any of the client applications, such as the live viewer or the config tool. Just as a side note, our auxiliary archiver can be counted as a client application as well, as it receives the video stream from the gateway. Now when looking at our recorded video stream down here, The only change is that the source is the archiver the video unit has recorded to, and the destination is most commonly the archive player client application. Overall, the order of the chain from source to destination will not change, but depending on the network type, we may be able to bypass some of the links. This is where video redirection comes in, as the stream can be redirected at either the archiver or gateway in order to reach the final destination, which are the client applications. Now that we know what video redirection is, we need to take a look at the various connection types. In Omnicast, the connection type is very important. If we're seeing a waiting for signal problem, we should always start by checking the connection types of the various components. Omnicast uses the connection types to determine where to send the video, and this needs to be configured based on your network setup. There are two main connection types we need to look at: the connection between the application or service and the gateway, and the connection between the video unit and the archiver server. Examples of the applications would be the config tool and live viewer, for instance, and services would be the archiver and virtual matrix, just to name a few. The connection between an application or service and the gateway can either be in multicast, unicast, and TCP, in unicast and TCP, or just in TCP. There are other connection types that can be made between the video unit and the archiver server, depending on the network and what the video unit supports. By default, the connection type for a video stream is set to best available. The connection types available are not always the same depending on the stream selected and the video unit make and model. We can force the connection type into multicast, unicast UDP, unicast TCP, RTSP over HTTP, and RTSP over TCP. These all use different mechanisms to transfer information. We won't go into detail about the differences between them here, but the video redirection document that will be posted on the GTAP will cover the ports that each one uses. This will help you set up your firewall and network connections. Now, how would we go about verifying our connection types? The first place to start is the Gateway Connections screen. From the Config tool, go into the Physical view, click on your gateway, and then click on the Connections tab in the main screen on the right. Each connected application or service is listed and shows the connection it is using at the moment, either multicast, unicast, and TCP, unicast and TCP, or TCP only. This connection information is shown for both communication directions, from the gateway to the application or service, and to the gateway from the application or service. You shouldn't see any surprises here. It should really reflect what you know to be the connection type between the gateway and the other components on the network. If something doesn't match up, you may need to go back and verify the network setup. One other thing to note is you should see the same connection type in both the from and to gateway columns for a particular application or service. If you're seeing a difference, there may be a problem with the configuration or a network issue. The connection type between an application or service and the gateway can be forced to a set type or determined automatically. The gateway does a connection test when an application or service tries to connect to it, and this will automatically determine the connection type. If you want to use a particular connection method, you can force the connection type instead. From the client applications, you can click on Tools, go to Options, choose the Network section, and then specify the network type. We can force the gateway to one of the connection types by going into the Server Admin, clicking on the gateway, and clicking on the Advanced tab on the right. We can set the default supported connection type from here. We should also make sure that the Enable Video Redirection box is checked as well. Now, if we're using gateway IP filtering, We can also set the connection type per IP address in the supported connections column. Between the video unit and the archiver, we can force the connection type by going into the Config tool and in the logical or physical view, choose the camera we wish to change. From the Video Quality tab, we can choose the stream usage first. We can have multiple connection types based on the video streams being used for live viewing, recording, remote viewing, and other connections. You can then select each video stream from the top of the Network tab and choose a connection type for each one. Please note that not all the streams support all the same connection types, depending on the model of the video unit. Also, depending on the make and model of video unit being configured, you may need to change the connection type on the unit entity in Omnicast. If you see a message that says same as unit in the network connection type for the camera, go to the physical view, click on the unit entity this camera is attached to, and go to the specific settings tab. You should be able to choose the connection type from here. Now, when we set the connection type between the unit and archiver to multicast, the video stream can go directly to the archiver server and also to the other components at the same time. If you specify any other connection type, it will always go through the archiver before going on to the other components. It must take one route or the other. Before going on, I want to cover what the best available connection type is doing. If a unit is set to best available, it will cycle through the supported connection types for that model of video unit for the stream selected. If the video stream is just going to the archiver, it will set the connection type to Unicast. However, if someone requests the video stream from a client application, it will switch the connection to multicast. If we don't have multicast supported, it will just choose Unicast instead. Now that we know how the connections are connected with the various components, we'll take a look at the redirection scenarios. Now we're going to present some network diagrams in the coming slides, and I'd like to explain what the various parts of the diagrams mean. Solid bars on the diagrams are for connection types, red is for a multicast connection, and green is for a unicast connection. The arrows are the video streams, either live or recorded. Again, red is a stream using multicast, and green is using unicast. We'll take a look at the live video scenarios first, which will only use multicast and unicast video streams. First is our most common scenario and most efficient, which is the full multicast scenario. The connection types along the chain are all multicast, and as we can see, video will go from the archiver straight to the from the video unit straight to the archiver, and also straight to the client station. Now note that in this situation, we don't have any servers doing redirection. The live video stream is going directly from the source, the video unit, to the destinations, which are the archiver and the client station. After that, we have a scenario where there is a unicast connection from the unit to the archiver, such as video units connected over a WAN, a wireless network, or on a different network. And the video stream is redirected in multicast by the archiver directly to the client stations. This is commonly known as multicast by archiver, and it's quite common. Please note that some video units are designed to only stream in unicast and do not have multicast available as a connection type. Another common scenario is when we have the clients connected using unicast, which is our situation when we have remote clients. In this case, the video goes directly to the archiver and the gateway will send the video to the client. Since we have video coming into the gateway and going back out of the gateway, we have video redirectioning happening here. Next up, we have multicast between the video units and the archiver, unicast between the archiver and the gateway, and multicast between the gateway and the client applications. This is commonly seen when we have remote sites which have their own network, but are connected over a wide area network or WAN. Video is redirected from the archiver to the gateway using Unicast, and then the gateway redirects the video coming from the archiver to the clients in multicast. Now in this next scenario we have all unicast connections. We can see that the gateway will use a local multicast loop to redirect the stream more than once. Now after that we have the scenario where we have a unicast connection between the units in the archiver, multicast between the archiver and the gateway, and unicast again between the gateway and the client stations. The video must be redirected at both the archiver and the gateway in this case. The next scenario is multicast from the unit to the archiver, but the rest of the network is using unicast connections. Redirection is being done at both the archiver and gateway servers. The red arrow over the gateway is the gateway creating the local multicast stream again, and it's doing that to replicate the stream data, sending the stream to itself in multicast, and then redirecting it to the other clients in unicast. In the last scenario, we have unicast from the video unit to the archiver, and unicast from the archiver to gateway, but then multicast to the client. The gateway does the multicast video redirection to send the stream to the clients. In this case, the archiver is only connected to one gateway and doesn't need to send multiple instances of the same stream. So next we're going to take a look at the playback stream, which uses the same connection legend, multicast in red and unicast in green, but the playback stream is always blue, as it is always in unicast TCP. This makes for very good playback since the archive player can buffer the incoming video and make sure it receives all the required packets. Since we don't have the video unit in the picture and the source is the archiver, the different redirection scenarios are pretty straightforward. Our default configuration is the network where the connections all support multicast. In this case, the video footage goes straight from the source, which is the archiver, to the client application. Our next scenario is where we have a unicast connection between the gateway and the client applications, and a multicast connection from the archiver to the gateway. We would see this if we had remote clients connecting to the main system to view video. In this case, the video is redirected from the gateway here. We can see the same thing for a unicast connection between the archiver and gateway, and with multicast supported from the gateway to the client. This would be a good example of a system that has a main site with remote archivers at other locations. The redirection again is being done by the gateway here. Now of course our final scenario is the full unicast network. So this we have the gateway doing the redirection again. So now that we have an idea of the types of network scenarios we can be faced with, let's take a look at some of the most common configurations we have seen at client sites with some real-world examples. Now these are the most common configurations, so we're only going to cover 5 of the 8 scenarios we looked at previously for live video streaming. The configurations we're going to look into are a full multicast network, which is the ideal and most common configuration. Multicast by archiver, which is the second most common, remote sites, where reverse gateway may come into play, remote client stations, and networks that support Unicast-only. So first we'll take a look at the full multicast network, where multicast is used to optimize bandwidth usage on the network. As previously mentioned, the network equipment must be properly configured to support multicast. The switches on the edge must be level 2 switches and support IGMP snooping. And the switches at the core must be level 3 switches and support IGMP querying. So if we take a look at a network topology diagram, including the switches, we can see the streams going from the video units up to the edge switch, which supports IGMP snooping. The local traffic is filtered out, so only the total video traffic is sent over to the core switch, which supports IGMP querying. The core sends the video to the archiver, as well as sending any video streams requested by any of the clients. A multicast network with the proper switches and configuration will limit flooding on the network by not allowing anything to be sent back to the units or out from the archiver or clients, as is indicated by the arrows here. A network which has not been configured properly or does not have the right type of switches can cause multicast traffic to be broadcast over the network, causing flooding, which is very bad for bandwidth. One other note with respect to the network hardware: the maximum number of multicast groups supported must be checked on the core switches. The cameras will create multiple multicast groups along the lines of one group per video stream, with other considerations such as audio and discovery, which may add multicast groups as well. This must be looked into and planned ahead of time to make sure you choose switches that will be able to handle the multicast traffic you will have on your network. This is especially important on very large systems where multiple streams per camera can generate a large number of multicast groups. Now, if you're using multiple VLANs on the subnet, we need to enable multicast routing between the VLANs or subnet. For example, this can be done on Cisco switches by enabling the PIM protocol. By default, Omnicast will use multicast addresses starting at 224.16.17.1 on port 47806, but this can be configured differently in the server admin if required. So taking a look at our multicast network, you can see that all the connections are in multicast and all the machines are connected over LAN. This is a typical setup where all the components are on the same local network and most likely at the same location, such as a hospital or secure office building. As mentioned, we'll be releasing a document on the subject to go along with the webinar, and in the document we'll have a list of all the ports that are used by the various components on the system. For now, we'll just take a general look at the system to see how the data is flowing and any redirections that happen along the way. So if we take a look at how the live video stream is flowing on the network over here, we can see that the video stream that will be recorded going from the unit directly to the archiver. And the live video stream is also going directly from the unit to the client applications. In our playback diagram on the right here, we can see the TCP playback stream going directly to the archive player from the archiver over the LAN. Now we'll see our second setup, multicast by archiver, when the network between the video units and Omnicast does not support multicast. This could be because the units are on a WAN or a wireless network, or the unit does not support multicast. In this setup, the rest of the network between the servers and the client stations supports multicast. One thing to note is that the archivers in this kind of setup usually have multiple network interface cards to be able to access the Unicast network and the multicast network at the same time. So be sure to check the archiver service and the extension settings in the server admin to make sure they're assigned the correct NIC. Now, as mentioned before, we need to verify that the networking equipment has been configured properly and can fully support multicast on the local area network. In the multicast by archiver setup, the live video goes through the archiver whether it's for recording or for live viewing, since the client does not have a direct link on the network to the video unit. The incoming Unicast stream is redirected by the archiver to the rest of the network in multicast. Now, just as a side note, since all the traffic is passing through the archiver, we need to remember that the load on the archiver must not exceed 300 megabits per second, counting both the incoming and outgoing video streams. So let's take a look at the network diagram in this case. We can see we have a unicast network between the video units and the archiver, and a multicast network between the archiver and the rest of the network components, including the gateway and the clients. We can see the Unicast video stream is going over the Unicast network from the video unit to the archiver, which is then sent directly to the client for live viewing via multicast. Looking at the playback stream on the right, since our connection between the client and the archiver is on a LAN and supports multicast, the TCP playback stream is going directly from the archiver to the archive player and other client applications. If we take a look at a real-world example, we'd have our main site with the local area network encompassing all the clients and servers. In this case, let's say it's the head office for a railway company. Outside of our main site, we may have remote cameras that are watching specific sections of tracks or switching stations. These cameras may be connected over a WAN or may be wireless due to their location. You can see we have our remote camera up here watching the track crossing at Main Street, and this is our railway head office here. The video streams from the remote cameras are coming into the archiver at the head office using Unicast, which is then distributed to the clients over the LAN by the archiver. For the recorded video stream, the client application is connected directly to the archiver via multicast, so the recorded video is going straight from the archiver over the LAN to the client applications. Now let's take a look at remote sites, where we have a main site at one location and a smaller system at another location. The network between the two locations does not support multicast, as they're on a WAN or connected via the internet or a private network. A remote location can just be one single archiver server with its own cameras, or it can have its own viewing stations as well. If the remote site has local clients, it will be connected to the main location using reverse gateway, where the gateway on the remote site connects to the gateway on the main site. Looking at our network setup diagram, we can see our main system here, and with the main gateway connected via multicast and its local clients over a LAN. For example, let's say this is the head office of a bank. Outside of that, we have our two remote sites connected over a WAN using Unicast. These are our bank branches spread out over the city. In our first site on the right, we just have an archiver server and some local video units. This may be a smaller branch without anyone on site who would be monitoring the local cameras. The communication between the archiver and the video units is in multicast, as they are on the same local area network. Our second site on the bottom is a larger site with security personnel on site who would be monitoring the local cameras. This site also has a multicast network locally, but since we have local viewing stations as well as video units at this site, we also have a gateway service which is connected via reverse gateway to the gateway at the main site. The reverse gateway allows local viewing in multicast and remote viewing in Unicast. So taking a look at our diagram with the live video streams, we can see that at the main site, the video feed between the gateway and the clients is in multicast. At our remote sites, the video streaming is also in multicast from the video units directly to their archivers or their client applications. From the servers at the remote sites, we're going over the WAN to the main site, so the video stream is being sent in Unicast. We have 3 points of video redirection, starting with the archiver here, the reverse gateway server and archiver here, and as well the archiver right over here. The settings for the reverse gateway are very important, so if you have any questions on your network setup and using reverse gateway, please do not hesitate to give the GTAC a call. So looking at our playback diagram, the video goes straight from our archiver servers at the branches to the main system gateway at the bank or head office, and then is redirected to the clients from here. We also have the redirection happening, or the video stream going locally to the client from the archiver over the multicast network. Our next setup is for remote client stations. Remote client stations are workstations that are not on the same LAN as the gateway server. Very often the remote station will be connected over a WAN that does not support multicast, such as with VPN access or over the internet. Some examples of this are if someone is working on the system from home, or if someone is monitoring multiple sites remotely. The gateway server will send a Unicast video stream for each camera requested by the remote client station. Again, we'll want to make sure that we don't exceed the maximum throughput on the gateway server of 300 megabits per second total. So let's take a look at our network diagram. We can see our remote client here, which is connected via Unicast. In this example, let's say the remote client is the chief of police, who is remoting into the local police station from home using a VPN. He may be doing this to investigate an incident or check on something that is currently happening at the station. The rest of the network at the police station is supported in multicast over a LAN. So this means that our live video stream from our video units will travel over the LAN directly to the gateway, and the gateway will send this stream to the remote client in Unicast. Excuse me. This means that that basically what we're showing here is it's a single connection as well. So if we have multiple cameras being viewed, we would also see multiple Unicast streams. Now, when viewing recorded video at the remote site, the TCP stream is being sent from the archiver and the gateway over the LAN, where the stream is being redirected to the remote client. In a Unicast-only network, there are no multicast connections at all between any of our 4 main components. In this situation, we can force the gateway in Unicast UDP in the server admin in order to accommodate the network environment as we've previously seen. All the video traffic, either live or playback, will pass through the gateway server and the archiver servers. And once again, I would just like to note the 300 megabits per second limitation on the archiver and the gateway as well. Now, one very important thing to mention is that an Omnicast system on a Unicast-only network can only have one main gateway. Taking a look at our network diagram, we can see that the whole network only supports Unicast connections. For our example, let's say this is a school system that is spanning a city. We have our clients at the police station who are remotely logged into the server at the school board. This server is getting video from an archiver at a high school across town. And the archiver is recording the video streams from the local cameras, who are connected on a wireless network which only supports Unicast. So for live video, it's going from the video unit here, redirected at the archiver here, up to the gateway, where it's using local multicast redirection to send the stream to multiple clients. For the recorded stream, it goes from the archiver at the school to the gateway at the school board, where it is redirected and sent to the client at the police station. Now, just give me a quick second. We'll go and take a quick look at the main points on video redirection. The video redirection in Omnicast is where the video is being rerouted at either a gateway or archiver server in order to get it from a source, which is either a video unit for live playback or an archiver for playback of recorded video, to a destination which can be one of the client applications. There's always a specific order to how the video will be traveling through the network. You can skip parts depending on the type of network connection we have between the components, but we can never have the components out of order when sending the video stream. In a live video scenario, the video stream starts at the video unit, goes to the archiver, then to the gateway, and finally to the client station. When sending archive video, the video stream starts at the archiver, and then goes to the gateway, and finally to the client application. We could have a case where the video goes from the video unit to the archiver, and then is redirected right to the client application, skipping the gateway because of a multicast connection between the client and the archiver. However, we'll never see a case where the video stream goes from the video unit to a gateway and then to an archiver. The client applications and services connect to the gateway using one connection type, which can either be multicast, unicast, and TCP, unicast and TCP, or just TCP alone. The video units connect to the archiver using another connection type. Not all video units support all types of connections, but the various connection types supported can be a subset of the list here. So when a service or application attempts to connect to the gateway performs a connection test to determine what connection types are available. You can see what types the gateway sees by going to the Gateway Connections tab in the physical view of the Config tool. This represents the information going to the gateway and from the gateway from the application or service. Now what you see here should accurately reflect the way you have the network configured. If you see anything that doesn't match, there may be an issue with the network or a configuration problem. If you do not see the same information in the from and to columns of a service or application, you know there's a connection problem between them. If you want to force a particular connection type, this can be done in the Advanced tab of the Gateway service from the Server admin, or from the Network options of the client applications, or on the Camera's Configuration tab. The best available connection type will cycle through the connection types until it finds one that works. If the video stream is just going to the archiver, it will choose Unicast for the stream type. If a client tries to view the video stream, it can switch over to multicast if available. So looking at all our various network scenarios, we can see that the live stream is being redirected at either the archiver, the gateway, or both, depending on the connection between the components. The exception to this is the full multicast network, where no redirection is being done, and the video stream can be sent directly to its destination client application, as well as the archiver at the same time. The same goes for the playback of a recorded stream, except it's only being redirected at the gateway in a situation where we do not have full multicast support on the network. In cases where the live video is coming into the gateway and leaving the gateway in Unicast, the gateway will use an internal multicast loop to replicate the stream for redirection to multiple clients. In terms of the networking equipment used, we need to make sure the edge switches are level 2 switches and support IGMP snooping, and the core switches are level 3 switches and support IGMP querying. We also want to make sure they can handle the number of multicast groups that are required by the video streams on the network. In general, it is one multicast group per stream, plus some extra groups for overhead, such as audio streams. If you're using multiple VLANs, you'll need to make sure you've enabled multicast routing between the VLANs. Now, since we just went over the examples of our common networking configurations, we won't take a look at all of them again, but I'd just like to touch on some important points for the different configurations. In the full multicast network, this is our most efficient configuration, since the video streams for both the live and recorded video are going directly from their sources to their destinations. We see the multicast by archiver configuration when we have video units that are connected remotely or that only support a unicast connection. One important step to check is the archiver service setup in the server admin to make sure that the NIC selected for the archiver service is on the multicast network and the services are using the NIC for the unicast network. In this case, our archiver is doing the video redirection from the video units right to the client applications. In our remote site scenario, we have archivers and video units at locations that support multicast locally, but the connection between the sites and the main site is Unicast-only. The redirection in this case is being done by both the gateways and the archivers. If we have a site that has local clients and cameras, we need to use a reverse gateway connection to the main gateway. We can also have a scenario where we have remote clients connected to a full multicast site. They will be connecting in Unicast, such as over VPN or the Internet. In this case, the stream will go directly from the video unit to the gateway, which will be sent out to our remote clients. The last configuration we see at client sites is the Unicast-only site. Note that at each step along the network we have video redirection, as there are no direct connections that can be made in multicast. So now we'll move on to our frequently asked questions. So our first question, why am I seeing a waiting for signal message in my live viewer or config tool? The waiting for signal message comes up when the client application is able to connect to the video unit and knows it's online, but it cannot receive a video signal from it. One of the typical causes of this is the connection type between the video unit and the archiver is set to a type that is not supported by the network. You can try a different connection type to see if this is the case. Another thing to check is that the firewall on the server or the client station is not blocking the ports that are being used by that type of connection. There also may be a firewall on the network that may be interfering. If the video stream is being redirected at the archiver or the gateway, try to view the video stream from the archiver or gateway server that is doing the redirection. If you can view the stream at the server, the problem is somewhere between the server and the client workstation. Similarly, you can look for archive video for that camera to see if the stream is getting through to the archiver. If it's not recording, you can always try to manually record for a minute. This way we can see at what step in the redirection process the video is not getting through. Worst comes to worst, you can run a network trace to find out where the packets are stopping. So our second question, why is my network being flooded with traffic? If you're having a flooding issue, the first thing you want to check is the switch configuration and specifications. Some switches say they support multicast, but in reality they're only broadcasting the multicast stream on all the ports. You'll also want to make sure the switches meet our requirements. Edge switches should be level 2 and support IGMP snooping. Core switches should be level 3 and support IGMP querying, as previously mentioned. In some cases, you may need to manually force the connection type to stop the multicast traffic. In a full Unicast network, you'll need to do this from the gateway service, from the network configuration screen of all the client applications, as well as the network configuration settings for all the cameras as well. We mentioned this earlier in the webinar, but if you need any help with the connection configuration, please give us a call and we can help you out. So question 3, why is my gateway connection only showing some of the connection types? If you're only seeing certain connection types between an application or service, it may be that the network does not support the type of traffic that is missing between it. For example, if you have a live viewer that only shows UDP and TCP, it may be on a remote network that does not support multicast. This could also have been manually configured as we described in the previous question. We may have forced the connection to Unicast, which is why we're not seeing any multicast connection between the gateway and the live viewer. If the connection has not been forced and should be supported, you want to take a look at the switch and network setup to make sure nothing is getting blocked along the way. Question number 4. Why can recorded video be viewed properly, but not the live stream? The recorded video and live video typically use different stream types, so it's possible that the stream being used for the recorded video is not restricted, but the ports used for the live video stream connection are blocked. Since the recorded video is also using a TCP connection, it will try to retrieve and reorder any lost packets, which is why you may be seeing artifacts or other problems in the live stream, but not in the recorded video. And our last question we sometimes get is, how should the firewall be configured? Now, the different stream types use different ports, which will need to be unblocked on the firewall. And as I mentioned, we'll be coming out with a document to complement this webinar, which will have more information, including the ports used by the different scenarios. So this concludes the webinar for today. We're going to leave the webinar session open for another 10 minutes or so in case you have any other questions. If you think of a question or have a comment on the webinar, you can always post it in the GTAP forums as well. Comments and feedback on the GTAC Tech Talk webinar series are always appreciated. On behalf of myself and the Genetec Technical Assistance Center, I would like to thank you for attending and hope you have a very good day.